All right, Rust book. Let's talk about it. So I did the thing that is basically the reason why I stopped doing the malware dev in C++ series, or the RRE series, as I've kind of called it. Um, I dove into a language, started using it, and very quickly realized that I didn't understand it well enough to be using it at the depth that I was. Rust is awesome. Rust has lots of quirks that you need to learn and understand in order to properly write good Rust code, or in order to not bang your head against a desk repetitively over and over again, trying to deal with the same problems. So what I decided to do, instead of throwing away the series that like everybody loves, is I want to actually dive into like the official Rust documentation and start learning it the correct way. The correct way meaning like the way that they intended, the reason why they wrote the Rust book. So if you're not familiar with the Rust book, it is basically the official documentation for learning Rust. It is a fantastically written book. It goes deep into things at the correct time and explains things fairly well to somebody who has either jumped into Rust from a different programming language or is completely new to programming and is wanting to learn Rust. I would recommend the Rust book to basically everybody. It is at least a really good jumping off point for learning Rust. So that's going to be what we're diving through. The chapters that I'm going to be covering are chapters 1 through 3. I can actually go ahead and pull up the Rust book, I guess. So right here, this is my blog on the Rust book. Let's do Rust book. You can find it right here. If you go to rustlang.org, read the book. We are going to be covering chapters. Ooh, we need dark mode on desperately. Where's dark mode? Please. Cole, that's what we're looking for. We're going to be covering 1 through 3, but less of 1. We're going to kind of breeze over most of 1 because 1 is how to install Rust. And there's no point in doing a whole video on how to install Rust. I'm not helping anybody there. But I did want to cover one of the biggest reasons why I was initially like falling in love with Rust, and that is cargo. If you want to know what cargo is basically how you do everything in Rust, or how you can do everything in Rust. Instead of compiling things into an executable and then running it, cargo is a build system. Cargo is a dependency management system. It is very, very similar to NPM if you've done any kind of JavaScript. I compared it to NPM multiple times in the blog. I'm sure tons of people are going to get pissy about that, but it is very, very similar to NPM. So if I wanted to run this program, for example, I could do cargo run. Obviously it prints out hello world there. If I wanted to add a dependency to it, cargo install Serday. So Serday is like a JSON parsing library. I could do cargo install Serday. And the next time I build it, if I'm using Serday, I think you can just do use Serday. Not user, use Serday. Okay, so I didn't actually need to do that. And then cargo run. Oh, I actually did do it wrong. Cargo add Serday, I think. There you go. Cargo run. So now it's going to install Serday exactly like NPM would, and it runs it. Everything's fine. Okay, so cargo is awesome. Cargo compiles everything for you. Once your program gets more complicated, you're using multiple sub-libraries, and the compilation is a little bit more difficult. Cargo is going to handle a lot of things for you. On that same exact note, I like cargo toml files way more than package.json files. If you've ever written any React or any Node code, honestly, at all, package.json files are absolute spaghetti. They're ridiculous. So instead, cargo toml files are incredibly simple. You've got your version editing, you've got the name of your package, you can put all kinds of other metadata in here, and your dependencies are just line by line. And you can get a little bit more powerful than this. You can use specific features of languages that are not installed by default. But it also can be just as simple as listing the dependency name equals and then the version name. Just keeps it simple. Okay, let's dive into chapter 2. So chapter 2, programming a guessing game. I did not, honestly, I kind of skimmed this. An interesting thing that the Rust book does. And I don't know how I feel about it, honestly. But an interesting thing that the Rust book does is they have project chapters and they've got like idea chapters or topic chapters, basically. I don't know how I feel about it, and I definitely don't know how I feel about them starting like basically from the get-go with a project chapter. So basically what this is it walks you through building a guessing game. It's a good way to kind of learn, but it introduces a bunch of topics that have not yet been taught to you. So it's kind of like, hey, here's all of the stuff that you're going to learn later, and then you have to go learn it. That's kind of weird. So instead of kind of talking over this chapter, we're going to jump right into chapter 3 and cover some of the stuff in chapter 3. So mutability is immediately one of the things that tripped me up, trips a lot of other people up. So if we've got, let's get rid of this hello world, basically to instantiate variables like you would in any other language. You use the let keyword and then you give the names. Let's do let x equals 7. Let y equals 10. Okay, so I can print line. The answer is, and it does formatting by default, which is cool. X plus y. Oh, you actually can't do that though. But you can do this. X plus y. All right, so if I run this now, the answer is 17. Okay, so these are both just normal variables. We can create another variable. Let our string equal hello. That's perfectly fine. It does give us some warnings that our string is never used. That's a great part of the compiler. It tries to basically clean up your code for you. So mutability is when you start getting into more complicated things like this. So y is equal to y plus x. Okay, so this would be a normal thing to do in any other programming language. So let's do, let's just do y is this, run it, we get an error. Cannot assign twice to an immutable variable. So variables in Rust are immutable by default, and what immutable means is they cannot be changed. This is different from constants. We're going to talk about that here in a second. But basically, in order for us to change a variable later on, we have to make it mutable. This is literally as simple as that. And now, if we run it, perfectly fine. Y is 17. So we are making y mutable explicitly. Anytime you want to make something mutable, you have to do it explicitly. That is kind of, from my experience at least, it's similar to missing semicolons and how frequently you're going to do it. Just like, oh shit, like I need to make this mutable so that I can change it in this line like 30 lines later. It's very important that you remember that, but making variables immutable by default is a good safety standard for Rust. That's why they designed it that way. It is a safety thing. So it's basically keeping you from creating variables that should not be changed and changing them later on. So that is mutability. Let's hop into data types. Rust has all of the usual data types. Rust technically is not a strictly typed language, I think, but there are a lot of like asterisks there. Basically, you can strictly type your variables. So let mute y u32. So that's an unsigned 32-bit integer. We can also do i32, which I believe is signed. We can do u64, I think, u8. There are tons of different types of integers. There are also multiple different types of strings and characters. We can also do let our car equal to C. So all of the standard variable types are there in Rust because it is a systems language. It also has all of the more granular types of integers and things like that. Strings are their own separate thing. There is a capital S string and there is a string slice. So those are two different things within Rust that deserve a lot more attention than I'm willing to give them in an already 10-minute long video. So I would say go and look at all of the data types. Scalar types, like I said, 8-bit through 128-bit, signed and unsigned integers. We've got floats as well, obviously decimal, hex, octal, binary. Floating point types being floats and decimal type numbers. It's got the numerical operations, and then your character types. So they use Unicode types, so you can actually do emojis inline, which is neat. Compound types, you've got tuples, you've got arrays. So arrays are fixed length by default. So that is something that's going to jack you up. Arrays are also one variable type by default, and I don't think there's any changing that. Tuples are, I believe, you can do mixed types with tuples. So if I've got let our array equal to 2, 5, 7, 9, perfectly fine. If I try to add 10.5, that's going to give us an error. 10.5 is a floating type variable, and the rest of these have been integers. So that's not allowed. Tuples are different, so let our tup, and we can explicitly type this here. So we can do I32, and then I think it's called F64, I32, and we can define our tuple that way. And we've got, let's say, 420, 69.0, and 45. That is perfectly fine. We have our typings here on the left after a colon. So here's all of our typings of the tuple, and here is our actual instantiation. So this is perfectly fine. This is not. Arrays have to be all of the same type. And that is applicable to string arrays, character arrays, all of them. Tuples, you can mix types. You just kind of have to do it in like a guessable manner, I believe. So that is arrays and tuples. That's it in the data types. Functions, very neat concept in all of programming, but especially in Rust, because Rust has some interesting syntax and an interesting way of handling return types or return variables. So we're not going to get into kind of the complexities of ownership until the next video, but we can at least talk about functions here. So let's do function our func, and we're not going to pass anything into it, and we're going to return 5. Okay, so if you're returning something, you don't have to put a semicolon after it. Everything else you do have to have a semicolon. There are specific reasons there why it's got to be that way, but we don't really need to get into that. You can do the same thing that you can do in just about any other programming language by assigning it to a variable. So let our var equal to our func, call it. Now here's the problem. We don't have a return type that is actually like designated here. This is basically saying this is a null function and we're trying to return an integer of some type. So we can specifically say it is going to return an I32, and that casts this as an I32. If we instead wanted to make it an I64, we wouldn't actually have to change anything. This just expects an I64. Now, if for whatever reason we wanted to specifically state our var needs to be a U32, an unsigned 32-bit integer, we're going to have some issues here. This is expecting a U32, it got an I32. So we're going to have to make these match up, or we're going to have to do some kind of casting at some point. So that at least is very, very similar to other languages. Let's do another function. So obviously the syntax is fn function name, parentheses that are going to hold the parameters that you store in it, then a single arrow and the return type. This can also be a tuple, it can be an array, it can be all kinds of different things. So we can also do function our other func, and we're going to pass in, let's do x, which is an I32, let's do y, which is also an I32, and we're going to return an I32. So we are going to return x plus y. And we can do that here. Let's do let z, which is going to be, I think, an I32, right? Equal to our other func. We're going to pass in x and y. So we can assign that to z, and everything is pretty normal. So there's just not, until you get into ownership and some of the more complex topics in there, there's not just a ton of difficulty or difference between Rust and other languages. That said, ownership is kind of a bitch of a thing to understand within Rust. And it's something that I'm going to spend quite a bit of time on in the next video. But I'm going to kind of leave it alone for right now, because again, it's something that I need to research more and is going to take quite a long time to explain properly. Comments. So not really much of a point in spending too much time on comments. Double slash. Everybody watching this channel probably at least understands what comments are for and probably underuses them as much as I do. Now, control flow, there's some cool stuff in control flow that's probably stolen from functional programming. I don't know enough about functional programming to really know, but there's some cool stuff in here that honestly is kind of worth going over, and it's not until we get over to loops. So ifs are pretty much the same as any other language. You can use ifs in a let statement to assign things to a variable. So we can go over here and say, let's see. So let's get rid of all this stuff, kind of get rid of some of the clutter and kind of restart. So let x equals 8 and let even equal to if x %2 is equal to 0, then true, else false. So this is kind of neat. Basically, we're saying if x is divisible by 2, then even is true, or else it's false. So that's a perfectly fine thing to do. I think that probably is present in lots of other languages that I've used. I've never used it that way, so it may just be like me not using it correctly in the past with Python or any other language. But here's where we get to kind of something cool. There is a generic loop operator within Rust that I actually like a lot. So the generic loop operator is just loop. So loop, and we're going to print line repeat. Now, left alone, this is going to be an infinite loop, okay? Nothing super surprising there, just an infinite loop. But if we add an index, so let's do let mut index equal to 0, we're going to do index plus equals 1, and if index is equal to, let's say 100, not string, number 100, then we're going to print line repeat 100, and we're going to break. All right, so if we run this now, it's going to do exactly what we would think it would do. It'll repeat 100 times and then print out repeat 100 and break. So break is going to break out of this loop. Now here is where stuff kind of gets cool. You can do nested loops. So let's say we're going to get rid of that break and we're going to name this loop, I think it's top loop, right? Maybe it is, let me look back at the book. I actually haven't used this a ton, but it is kind of a cool part of Rust that I think I'm going to end up using more. Let's scroll down a bit. Named loops. Nope, don't want to do that. Name. Let's see. So you can store a loop within a variable, which is kind of cool, or store a loop return value within a variable, which is kind of cool. Damn it, now I've got to find, there it is. Okay. So that is how you do it. You put it over here. So you can name your loops. And the reason why you would do that is if you don't want to, basically loops are good for if you don't want to have like the specific operating conditions of say like a for loop or a while loop, you can just use like loops as generic items, and you can loop over them like in unique ways, especially by using naming conventions like this. So let's create another loop in here, and we're going to name this inner loop, and we're going to print line that 100 times. Now, if I were to just break out of this inner loop, it would keep going in the top loop. If I wanted to break out of the entire loop, I could do something like this. If index is equal to, let's do 300, break. Now, if I just left it at break, it would just break out of the inner loop, right? So we could go here. It's going to repeat 100, and it's going to keep going. Oh, we never did this. Index plus equals 1. So then it breaks out of that repeat 100 loop, and it continues in the top loop. Now, if I decided, let's break out of top loop, right there, actually, that's the wrong syntax. It's a space there. So if I want to break out of the top loop, so break out of this entire loop right here, I can do that just fine. Breaks out of repeat 100 and breaks out of the top loop. Okay. So that I think is kind of cool, and it creates like a cool condition where you can, have like nested loops and it not be an absolute mess. Named loops, it may be present in other languages. I have a feeling it's probably present in functional languages. But one, the generic loop idea is just kind of cool. And two, like this unique way of breaking out of loops by name is cool. I don't know, maybe, but that does sound like a functional programming concept. But I also wanted to go a little bit into constants and their difference between the difference between mutable variables and constants. So the sort of idea is the same. Constants being things that cannot change. That sounds the same as an immutable variable. So if I do let x is equal to 7, this is not mutable. It cannot change later on. However, it is not defined like explicitly. An immutable variable can be defined at runtime, especially if I did something like this. So use standard IO. Standard IO is input output, and we can do IO read line. I think it's in IO, yeah. No, it's not. Standard IO read line. Let's see. I thought it was in read line, maybe somewhere else, or I thought it was in IO, maybe somewhere else. Let's see. I bet it's in standard and read line. There we go. All right. So get rid of this. We're going to do a reference to a string that we're going to create up here. Don't worry about this syntax. Let mute our str is equal to string new. This is going to be and our string. That should be fine. Good to go. It's not. I guess it needs self. Okay, let me go back and see how they do it exactly. IO standard in. Okay, that's what it is. IO dot, and it's just read underscore line. There we go. Read underscore line. All right, so now we should be able to pass in a reference to our string and be good. We cannot. Oh, it's got to be a mutable reference, which, again, something that they explain later, something that we will talk about later. So basically what this is going to do is it's going to read the string in here at runtime. Okay, that's important. So what that means is that when we run our program, X is going to be defined. So if we wanted to print line, your string was, and then do X, then dot expect. Again, another thing that we will explain later. This isn't valid. Just have to have something there. And if we run our program here, it'll wait for us to type something in. Your string was 11. That's wrong. Huh. Guessed. That's weird. Oh, no, it's supposed to be our string. That's why it was wrong. Something. Your string was something. Okay. So this is defined at runtime. A constant is defined at compile time. That is important. I know it doesn't necessarily sound important to begin with, but it is important. So if we were to do const, let's just do our const, which is going to be an I32. I'll explain all of this in a second. And we're going to do 420. Okay, so this is defined specifically when you compile your program. X or our string are both defined when we run our program. So if we do cargo run, okay, we do something, our string was something. If we were to run it again and do something else, we would get something else. Okay, so the importance here is regardless, our const is going to be 420 as soon as we compile it. Okay, it doesn't matter. You can't change it down the line, so we'll get a compile error if we try to change it. Const is equal to 421. Okay, we're immediately getting problems here with linters. We're not allowed to do any of this stuff. Okay, if we run this, we're gonna get a problem. Okay, you cannot change our const. You also cannot change immutable variables, but even immutable variables are going to be defined at runtime. You know, even if you like hard code the value in, I believe then it will be like there's optimizations that are going to make it defined at runtime or at compile time, but here X is defined at runtime. Even if it's an immutable variable, it's defined at runtime. Here, our const is defined at compile time. Those two things are important. They're going to be important later on, especially, but this video's gone on for like 20 something minutes now, and there's no point in it being that long. That is about it. This book is rad. Go check it out. And I hope you join along for the rest of the series. Take it easy. Peace.